How do you specify resistors in the circuit in order to meet design criteria? Find out right now. Hi, I'm Dr. Buck. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. In this Networks Chapter 2 style problem, we're given a circuit diagram with a current source and 4 resistors, R1, R2, R3, and R4, with 5 currents that is supply current I sub S, current I1, I2, I3, and I4 through the resistors. The problem is to specify the resistors in the circuit in order to meet the design criteria. The design criteria are here. I sub S is given as 100 milliamps. V0 across the input power supply, which is a current supply, is 4 volts. I1 is 3 times I2. I2 is 5 times I3. And I3 is equal to I4. In order to solve this problem, we're given a big hint right up front. First off, we're told that V0 is equal to 4 volts. That's going to give us the total resistance. So our total is going to say RT is equal to, let's see, V0 over I sub S, the supply voltage, which is pretty straightforward. So 4 volts divided by 100 milliamps, which is I sub S, the total current supplied, and that's going to come out to 4 divided by 0.1, which is going to be 40 ohms. Alright, so the total resistance, that says the total resistance of this network, just looking from here on back, R1, R2, and R3, R4, is going to be 40 ohms. These 4 resistors are in parallel. So we have this 40 ohms, and that is equal to 1 over resistors in parallel, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Alright, we don't know what these 4 resistors are just yet, but this is our formula. We can write some relations between these formulas right here. What we also know about these currents is that these currents and these resistors, they all have to add up to their own numbers. For example, we look at I1 times R1 has to be equal to 4 volts. Okay, we know that, right? Because this is 4 volts from here to here. That's V0. That's across the top. This is 4 volts all the way over here on all this branch. Everywhere is 4 volts over here. Down here, we're going to call it ground, which is going to be 0 volts. Now, that also means that I2 times R2 is also equal to 4 volts. I3 times R3 equals 4 volts, and I4 R4 is equal to 4 volts. But here we notice that I3 and I4 are going to be the same. They're equal to each other. If these 2 currents are equal to each other, then R3 and R4 also have to be equal to each other. So that's probably going to be something that we can simplify in this equation over here. Let's find relationships between these guys right here. So they're all equal to 4 volts, but more importantly, we have I1, R1 is equal to I2, R2, and it's also equal to I3 times R3. Now, we could add this I4, R4, but there's no point because we know these 2 are going to be identical. These 2 resistors are going to be the same. These 2 currents are going to be the same. So let's just forget about that and ignore it. But we do have these 2. So what we can do is simplify this and get everything in terms of R3. So we just solve for 1 resistor. We just want to solve for 1 resistor down here. And that's going to, once we get R3, we can get the rest. All right? So we have, in this case, we have a relationship I1, let's go back to I2 is equal to 5 times I3. So let's write that equation. Let's write that relationship and drop this in here. I2 R2 is equal to I3 R3. And then let's drop I3 into this. Well, let's see. Or let's drop I2 into this one. So I2 is equal to 5I3. So let's change that to 5I3 equals to times R2 is equal to I3 R3. These I3s cancel, and then we get a relationship between R2 and R3. We have R2 is equal to R3 over 5. Let's write that R3 over 5. Now, we also have a relationship I1 is equal to 3R2. Let's drop that in for I. So 3, let's use this relationship and say 3I2 times R1 is equal to I2 R2. And then the I2's cancel out, and we get a relationship here that says 3 times R1 equals to R2. But we also have this relationship here. So we already have a relationship for R2. Let's drop 3R1 into here is equal to R3 over 5. And that gives us a relationship for R1 is equal to over 5. Did it again, R3 over 5. And then this becomes R3 over 15. Now we've got a relationship for R1. We also have a relationship for R4 is just equal to R3. We know that from this equation right here. We know that these two are the same, therefore these two are the same. So let's drop these relations into our formula. And there's our formula right there. 40 ohms is equal to 1 over, well, R1 is equal to R3 over 15, but 1 over R1 is 15 over R3, plus R2 is equal to R3 over 5. This is going to be 5 over R3, plus R3, well, this is just going to be 1 over R3, and of course R3 is equal to, it's going to be 1 over R3. Okay, so there's our whole formula, and that can basically change into R3. We're going to flip all these, add them all up together. 5, 15, 20, 21, 22. Okay, so R3 is equal to 22 times 40 ohms. And that gives us our first basis. That is 880 ohms. It also gives us R4, which is also 880 ohms. And then R2 is going to be R3 over 5. Well, R3 divided by 5 is going to be, let's get our calculator out, 880 divided by 5, which is 176 ohms. And then R1 is going to be R3 over 15, so 880 divided by 15 is going to be 58.667. Okay, so we have all 4 of our resistor values. Let's go in and verify some of our notions about this. The first thing we said was that the total resistance is 40 ohms, which is equal to 1 over R1. So we said R1 is 58.67 plus R2, 1 over R2, which is going to be 1 over 176 ohms, plus 1 over R3, which is 1 over 880 ohms, plus 1 over 880 ohms. Alright, let's make sure all these are right. the first one's 58.6, I'm just going to 1 over x that, plus 176, 1 over x, plus 880, 1 over x, plus 880, 1 over x, equals, and then 1 over x, all of that, and of course I get 40 ohms equals to 40 ohms. So as you can see, we have a nice clean 40 ohms right there. Let's verify that the currents add up. That is to say, we know the total current is I sub s equals to 100 milliamps. But see, we have a node here, and all these currents should add up, right? That is to say, I sub s should equal to I1 plus I2 plus I3 plus I4, which incidentally is another way to work this problem out. It's another approach. But let's verify what they are. So first off, we want to find out what these currents are. Well, I1 is equal to, we said it's 4 volts is the voltage divided by the resistance, which is going to be over R1, 58.67 plus 4 volts divided by 176 ohms plus 4 volts divided by 880 ohms plus 4 volts divided by 880 ohms. Alright, so let's find out what these are. We have 4 divided by 58.67 equals I1 is, I sub s is I1, I'm just adding these up. I1 is equal to 0.062. Now, it's going to be more than that's going to be adding up too fast. 4 volts divided by 160 ohms is equal to I2 is equal to 0.0227 amps. I3 is 4 volts divided by 880, which is 0.0045 amps, and that's also I4, 0.0045. So I'm going to take that last number times 2, get a number, and then I'm going to add it to these two, 0.0227 plus 0.0682, and all adds up to I sub s equals to 99.999 milliamps, which is roughly 100 milliamps, which is what our voltage is, or what our current is. So I sub s, this comes out correct. That verifies, is there anything else we can check on this thing to make sure that our numbers are correct? I think we verified that this is correct. We verified that all the currents add up. So I think we're good to go. Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.